Edwards, and I am one of the co-directors of the science program here at the Radcliffe Institute for Advanced Studies. Thank you for coming out on a gray and drizzly day. I think you're going to get a treat. We have tonight coming from the Norwegian University of Science and Technology in Trondheim, Dr. Linn Getz, who is the professor in behavioral sciences and medicine there. The reason we have Linn is because we had a conversation she and I had at her house in Trondheim about a year ago, which was one of the most stimulating conversations I have had in a long time about medicine, social medicine, precision medicine, and who will get access to it and how can it maximize the health of populations. And I thought, wow, it would be great to bring Linn here. And it was Linn's idea to bring Bruce along as well, up from Rockefeller University. Bruce McEwen, who is somewhat of a household name around here for, if you think allostatic load, you think Bruce McEwen, is the Alfred Mirsky Professor at the Hatch Laboratory of Neuroendocrinology at Rockefeller. Dr. McEwen discovered adrenal steroid receptors in the hippocampus in 1968 that really opened up the gateway for all sorts of studies on circulating stress hormones, sex hormones, cognitive function, mood regulation, and other central systems via epigenetic mechanisms. And if you don't know what those are, I'm sure you will by the end of the hour. He's a member of the MacArthur Foundation Research Network on Socioeconomic Status and Health, so really studying the distribution of health and disease in society. And he is on the National Scientific Council on the Developing Child, which focuses on biological embedding of early life experiences and promoting healthy brain development. So I think what we're going to do is have Linn start out, and then Bruce, and then Linn will finish us up at the end. So Linn, why don't you come on up? Thank you.
Thank you, Janet. I'm so proud to be here. This is quite a place for me, and I'm a little nervous. If you hear it, it's correct. Here is the slide I prepared for us before I came, because I didn't know you had such a good slide. And here you can see the whole spectrum of the topic, from thinking at the left to multi-billion data measurements to the right-hand side and everything between. Thank you so much for making it possible to get here, and also for having the opportunity to meet Bruce. We have been communicating by mail and Skype since 2009, and now finally we met yesterday in person, and it has been already a treat, and it hasn't stopped yet. I come from Trondheim. It's a university city in the middle of Norway, and sometimes it feels like in the middle of nowhere. But
nowhere. Yeah.
Here we go. I used to be a general practitioner, that's a family physician. I used to travel in the north of Norway with a boat, going to visit people in the islands. I have met lots of regular people. I have also worked a lot in psychiatry, which I did in Iceland, and now I'm back at the university in Trondheim. And Norway, as you may know, it's a social democratic welfare state. It's not a socialist country, even though I think the Americans don't really make a difference there. We do. And we also have, for practical purposes, we do have equal access to health care. It's not perfect at all times, but we do have it, and it works. And I know that's different from what you have here. This is my city, Trondheim. It was founded in 997 by a Viking king, and through the Middle Ages, it was famous as a site of pilgrimage. People actually walked through Europe to get to this site of healing and salvation. It's the church above St. Olav, the saint. And now we have St. Olav's Hospital. That's the new site where people seek healing, and the Faculty of Medicine. And our little general practice or family medicine research unit is actually located exactly at the outskirts, as you can see, a little inside, a little outside of mainstream medicine. And this is my office. And I have a view from my window, and I see some things there which I would like to share with you. Of course, medicine has lots of successes. That is not why I stand here today. But I don't want to debate that. But there are also some areas of remarkable stagnation. For instance, an epidemic of so-called medically unexplained symptoms, or MUS, or even MUPS when it's physical symptoms. My tentative diagnosis of that epidemic is that there is too much doing and too little thinking in medicine. If you want to study medicine in Norway, you Google around and you can see what medicine looks like. And at our university, this is the first sentence describing the curriculum. To become a physician, you need to know the body's machinery right down to the smallest cell. And I think some of the thinking problems are actually rooted here. The body machinery, that metaphor, it can bring you to success, but it can also bring you astray. We did have a success recently when we got, or our faculty, I had nothing to do with that, the Nobel Prize for Medicine and Physiology in 2014. It doesn't often go to Norway. It quite often goes to Harvard or Rockefeller, but we got it for the brain's GPS, the metaphor of the neurons that make you orient yourself in space. What is even more interesting from my window is to see the groundbreaking evidence of the interrelatedness of human biology and biography. And whilst we are getting ever more knowledge about this and insight, and it pours out, the machine metaphor is starting to rust, but I cannot hear anything but the engines still roar out there. We are doing so much of the old-fashioned stuff, and I wonder when are we going to start turning this huge tank ship to another direction. And whilst all of this is happening, there is a persistent tension and suspicion between the humanistic and the techno-scientific camps in medicine. But what is happening is that the word person is coming up in both those camps, somehow independently of each other. The word person is a buzzword and it sells. Here you have the humanistic version, exemplified by the European Society for Person-Centered Healthcare, established in 2014. And you can see here, it says it's a humanistic project. And it's symbolized by the human hand, and I have, for myself, added the thinker, just to make sure that this is a critically thinking kind of movement. But then on the other side, in the other camp, you have something called, for instance, the Personalized Medicine Coalition. And that is quite another story with other metaphors. Here you have the high-tech metaphor going. And this has several names. Personalized medicine is where it started. And that is what people want to call it in Norway. They don't want to skip the word person. But in the United States and with President Obama, you are a little clever, I think, because you choose the word precision medicine, which is much closer to what it's all about. It doesn't have much to do with persons. That's my whole point. Sometimes it's called P4 medicine. I don't want to go into exactly what all those P's stand for. It's personalized, participatory, and all this. Systems medicine is another name for something very similar. And the whole point, we are dealing with billions of data points or big data, as you can see from this avatar figure that I stole from the internet somewhere. Now my big question that I really play with these days is how might this renaissance of the person concept affect clinical medicine in general, and particularly family medicine or primary health care at the very front line where normal suffering people meet the healthcare system. And of course, I'm thinking from a Nordic perspective where we try to have equal access and we have to think about sustainability and cost because we don't want to leave anybody behind. If medicine is flying decently high today, we do many good things. I wonder how it's going to be 20 years from now. And I have two scenarios, the best case scenario and the worst case scenario. And the best case scenario looks like this, the flying eagle. I think we have fantastic opportunities now with this new knowledge that Bruce will share some of it with you. But we also have a potential worst case scenario. We can get trapped in this new knowledge and we can lose sight of where we're actually going because high tech makes it possible to monitor everything known to man and a little more than that. So a couple of years ago, Bruce invited me to come in and co-author a paper that he was working with called Lifetime Experiences, the Brain and Personalized Medicine, an Integrative Perspective. And it's quite a mixture of his world and my world as a GP or family physician. And it's part of the project that we are like playing with on Skype and email. So I think I will stop now and leave the next minutes to you, Bruce, and you take us into your world. And I hope that this audience will appreciate as much as I have done all the knowledge that you are so generously sharing with people who don't know much about the brain.
Thank you.
So there you go.
Thank you. Thank you. Thank you very much, Lynn. It's such a wonderful pleasure to finally meet you in person and have this opportunity. This is really a highlight for me. And so, yes, I'm going to tell you a little bit about my journey into this. Of course, I'm at the Rockefeller University. I've been there since 1966 on the faculty. I was a student there. I will tell you more about it. Now, Rockefeller has no departments, only laboratories. And so it's been easier for me and others to do research across biomedical disciplines, and in my case, sort of expanding out to include the social sciences as well. My own progression was to be a student of Vincent Alfrey and Alfred Mirsky, who were actually one of the first to discover that histones are modified to regulate gene expression. So I've known about this thing we call epigenetics, even though it didn't have that term, since the 1960s. And then I went to Sweden. I had a 2-year postdoctoral fellow in the laboratory of a man named Holger Hudén in Göteborg. And I discovered the hippocampus. Didn't know much about brain anatomy, but it was a structure that was easy to find. And when I came to Rockefeller and then went to the laboratory of Neil Miller, who was a pioneer in what's called behavioral medicine, who was certainly interested in stress, we serendipitously discovered that it was the hippocampus and not the hypothalamus that had receptors for stress hormones, for adrenal steroids. And that's what started my progression, almost inexorable progression towards what we're talking about today. I was lucky enough to meet the late Elliot Steller, a physiological psychologist who introduced me to interdisciplinary research and got me into MacArthur Foundation networks, the Health and Behavior Network, the Successful Aging one I didn't work in exactly, but my colleague Teresa Seaman started there, and then the network on socioeconomic status and health, and now the National Scientific Council on the Developing Child. So somehow the idea that the brain, as we'll see, is the central organ of stress and responds to epigenetic signals. This I got off the internet, and since people hardly understand what it means, this is not genetics, epigenetics. Well, as you probably know, it refers to now above the genome, things currently that regulate gene expression and development and throughout the life course without actually changing the DNA sequence. Now, originally, when a man named Waddington used the term epigenetics, it referred to the emergence of characteristics from, say, compare a frog's egg and a human fertilized egg that look very similar. Well, the characteristics of the species and then even the individual begin to appear, and you couldn't have predicted them from the previous stage. So that was the original term. Now epigenetics refers to a whole series of changes, the methylation of cytosine bases on DNA, which is in many cases a reversible process, the histones, which allow the winding, unwinding, and winding of the DNA so it can either be read and transcribed or repressed and not transcribed. And there are other mechanisms that are emerging. So what is ironic is that it wasn't too many years ago when the people who sequenced the human genome said, now we know everything. And there are still people who operate only in terms of genes. A recent paper in Nature Biotechnology didn't mention the environment once and talking about gene interactions. But we know that environment is hugely important. And of course, the other message from the inexorable progression of development is that we can't turn back the clock. We have to talk about resilience and redirection and not reversal. So neuroendocrinology, as I've practiced it, involves the idea that hormones affect all brain functions and not just the steroid hormones, the metabolic hormones as well, that experiences affect the brain and the body through these mechanisms, and that behavior changes the brain. And one story in this whole idea of integrative medicine, there's a program at Cornell Medical School next door to Rockefeller, headed by a woman named Mary Charlson. And I was invited to give the integrative medicine grand rounds in the Department of Medicine several years ago. And after the talk, I went to, as the speakers do, to morning report. And there were two residents who were presenting a case of a woman who came in with an acute autoimmune and inflammatory disorder. And they proceeded to talk about the drugs that by and large did not work very well for her condition. And finally, I stuck up my hand and I said, so what was her condition when she came in? Well, she had just learned that her son had Hodgkin's disease. They may or may not have sent her to a social worker to help with the problem, but they didn't mention this as a primary factor and take, at least present it as it was a factor in how they then went about treating her. And this just indicates the siloization and the lack of regard for this lived experience that Linn introduced us to and we'll talk about further. So this is the diagram from this New England Journal article in 1998 talking about the central role of the brain. And I want to take you through some steps in explaining this diagram. First, the concept that we call allostatic load. The idea that allostasis is the active process of putting out cortisol and other mediators that help us adapt, and that's the purpose of these mediators, is not damage but adaptation. But when there's too much stress and when these responses are dysregulated, then an allostatic load or wear and tear on the body and brain can develop. So for example, cortisol is when it's put out acutely, it actually enhances immune function. It promotes energy replenishment, certain kinds of memory that will keep us away from danger to remember where danger lay, promoting more efficient cardiovascular function. But chronically, we know that it suppresses inflammation, suppresses immune function, can promote bone mineral loss and muscle wasting, and contribute to the metabolic syndrome. So we talk about an inverted U, and you will see inverted U-shaped dose response curve again in the talk. Now, cortisol is not the only mediator. It works together with parasympathetic and sympathetic, pro and anti-inflammatory cytokines, the other adrenal steroid DHEA, a little bit of oxidative stress, which is important for cell functioning, and it simultaneously affects multiple systems of the body related to the things you see on the slide. And it is as a result of the fact that these mediators interact with each other and influence each other's activity, it's nonlinear and as I said, biphasic. And it can be the dysregulation that can lead to allostatic load, can be related to an unhealthy lifestyle, including poor sleep, but exposure also to toxic chemicals. And these feed into this network of allostasis, for example, elevating inflammation, which then leads to an elevation of cortisol, which then can have adverse consequences if both stay elevated for long periods of time. And so these dysregulation, the allostatic load, is connected to disorders in various systems and parts of the body, from mental health disorders to immunologic disorders to cardiovascular disorders and metabolic disorders. And we know, and you'll hear much more from Linn, about comorbidities of diseases. So I've already mentioned lifestyle and being stressed out, our health behaviors, whether we lose sleep at night, eat too many of the wrong things, drink too much alcohol, smoke, and so forth, or neglect our regular moderate exercise, these things also play into this network of allostasis and can contribute to allostatic load. We have, of course, different kinds of stressors, trauma and abuse, major life events, but also the daily environmental stressors of our daily lives at work, at home, in our neighborhoods, and watching television in the evening and seeing what's happening in the world. And if we talk about stressors, and this is something, a terminology that's come out of the National Scientific Council on the Developing Child, we can talk about positive stress, like giving a talk, taking a challenge, and having a positive outcome. And to do that, you have to have a good sense of yourself, good mastery of and sense of control to make the right choices, to take the right risks. There's tolerable stress where something bad happens, a major life event. You have the good internal resources, and you have good material and social support, and you can weather the storm. There may be some allostatic load that results, but it can be attenuated. And then you have toxic stress, which involves a lack of sense of control, possibly because of poor social and emotional support, but also perhaps because of compromised brain architecture because of early life experiences, and we'll come to that shortly. So the brain is indeed the primary target of stress, and this has been work that we have done and are doing ongoing in the laboratory, and I'll tell you just a very little bit about it, involving 3 different brain structures, the hippocampus, where we first discovered these receptors, and we know the hippocampus is important for contextual and episodic and spatial memory, but also should be on this slide, for emotional regulation, mood regulation. The amygdala is involved in fear and anxiety and aggression. It also turns on the autonomic and hormonal stress response, just as the hippocampus helps to shut it off. The prefrontal cortex is important for decision making, for working memory, and for all manner of self-regulatory behaviors. And it has downstream influences on the amygdala to keep it from overreacting, and interacts with all of these other brain structures. And it helps to shut off the autonomic and hormonal stress response. So if anything happens to the architecture of these individual brain areas, it's going to affect the balance of how they relate to one another. And that's what we'll talk about. Because one of the discoveries of the last, growing over the last 30 or so years, is that even in adult as well as the developing brain, neurons are capable of what we call remodeling. That dendrites can grow or shrink dependent with experience. That in the middle synapses, these are excitatory synapses on what are called spines, that there's a certain turnover of some of them at least every day, mediated by the circadian cycle, which helps you in motor learning, and cortisol is very important in those changes, and that there is a certain amount of neurogenesis that actually occurs in the dentate gyrus region of the hippocampal formation. This was a revelation some decades ago, some of which occurred in my laboratory and also previously in the laboratory of Fernando Nottebohm at Rockefeller. Elizabeth Gould, who's now professor at Princeton, was the one who really rediscovered neurogenesis in the hippocampus. And now it's a big deal in relation to lots of things going on in understanding brain adaptation. So we come back to our inverted U-shaped dose response curve, and talking only about, just for the moment, about cortisol and these excitatory amino acid transmitters that are so important for cognitive function. Acutely turning on an acute stress response, it actually enhances excitability, improves memory functions, as I said before. But then if there's a more intense acute stress, it can actually have the opposite effect. So we see the first manifestation of the inverted U, impair excitability and impair memory, and we know the expression stress makes you stupid. Then if we have repeated stress, as I've already been saying, you have what we call adaptive plasticity, the suppression of neurogenesis and the causing remodeling or shrinkage of dendrites, or in some parts of the brain, actually the opposite, growth. And I'll tell you about that in a few moments. Then with a severe crisis, such as a seizure, stroke, or head trauma, the same players, glucocorticoids and excitatory amino acids, actually cause the permanent irreversible damage in these conditions. And so again, the extreme version of the inverted U, brain aging over activity of the glutamatergic system and of the glucocorticoid system contributes to the speed of brain aging and may even play into the acceleration of Alzheimer's disease. But then finally, we come to the loss of resilience. We know that after stress, these changes in the brain architecture, which are adaptive, if the stress is over, they should adjust. It's not turning back the clock, but adjusting so they'll go back to more or less the way they were before. But when that doesn't happen, one may have an anxiety disorder or depression, something that's inappropriate for the circumstances, and we have to intervene with some external means, with a drug or with behavioral interventions or both. Now, a lot of this work that's derived from animal models has been extended to the human brain by people doing structural and functional imaging. We know the hippocampus gets smaller in prolonged major depression. It also gets smaller in type 2 diabetes, which is often associated with depression. It's smaller in post-traumatic stress disorder, maybe as a precondition for the disorder and also as a result. It is smaller in Cushing's disease, but the good news is if you correct the hypercortisolemia, the hippocampus can recover over 6 months to a year. And both the mood regulation, the volume change, the cognitive dysfunction can be at least partially reversed. But you don't need to have a disease because we know there is smaller hippocampus with prolonged chronic stress, with chronic jet lag and lack of exercise, and also with chronic inflammation, which is a condition of many of the so-called non-communicable diseases of modern life. The good news is that regular exercise increases hippocampal volume, intense learning does the same, and antidepressants do the same, and one of the most effective antidepressants is exercise. An example of this from studies of people in their 60s and 70s who were largely couch potatoes until they were encouraged to get off their duffs and walk an hour a day, 5 out of 7 days a week. You can see on the top the enlargement of the hippocampus in 6 months to a year with improvements in memory and also changes in the prefrontal cortex and blood flow, which made them more efficient in decision-making and working memory. So even as one ages, these changes are still possible. And that encourages us then to believe that we can change the brain with behavioral interventions and not just with drugs. Metabolic hormones also affect the brain. They enter the brain, and they have very positive, important effects. For example, IGF-1 from the liver actually goes into the brain when we exercise, and if you block the IGF-1 with antibodies, exercise does not stimulate neurogenesis. So here's another example of a peripherally acting hormone that is essential for a brain function. Now, apologies for the black, but on the left you see that in the hippocampus and the prefrontal cortex, stress causes dendrites to shrink, and there is some resilience possible in the healthy brain. It also happens in a place called the medial amygdala, which is important for social behavior. But in the amygdala, especially in the basolateral amygdala, which is important for anxiety, these dendrites expand, and the animal becomes more anxious, more vigilant, because the orbital frontal cortex, which is involved in vigilance, also expands. So here you have the unbalanced brain architecture, which is very appropriate if you're in a dangerous situation. And so not only in adulthood, but also kids who have been abused early in life have a persistent condition like this, where they're much more vigilant and their amygdala is much more active as a result of these early experiences. We'll come back to that very shortly. So in adults, the amygdala is overactive in anxiety and depression. An effective treatment, as has been done at Mass General by Birgitta Holtzel and Sarah Lazar, of chronic anxiety can actually reduce the volume of the amygdala. An overactive amygdala and underactive prefrontal cortex is associated with early signs of cardiovascular disease. And most interestingly, if you elevate glucocorticoids at the right time, at the time of trauma or right afterwards, it actually reduces PTSD symptoms. So here, glucocorticoids have a protective role, and that's very important to emphasize because they're not bad guys, they're there to do good. In the prefrontal cortex, I was involved in a study on medical students during the course of their studies where there were differing levels of perceived stress. The ones who were the most stressed out actually had an impaired circuitry in their prefrontal cortex and did worse on tests of cognitive flexibility than those who had less perceived stress. The good news is when they had a month off for vacation, all these changes reversed themselves. They came back to normal. So the young brain is flexible in that way, but studies that we've done with John Morrison on the prefrontal cortex in animals show that as the animal gets older, it can show stress responses, but it's less resilient in recovering unless we maybe help it out. It's also affected by circadian disruption. And so, of course, again, maybe that can be treated. So the final part is really this whole question of individual differences, the effects of our gene by environment, epigenetic interactions, experiences that happen throughout the life course, especially early in life. And this concept sort of long-term influences has been referred to as biological embedding. There are variations on genes that are referred to as context-sensitive alleles, sometimes as orchid alleles, because they confer greater sensitivity to either bad things or good things, whereas the dandelions are tougher and don't show as much response. And of course, these epigenetic modifications, which are not confined to early development, this is a description of all the things that are happening to brain plasticity throughout the life course, but they are particularly potent early in life. So for example, studies of maternal care, currently by Michael Meany and colleagues, before that by Seymour Levine and Victor Denenberg, showed that if mothers nurture their pups intensely, they become more laid back, less anxious, and you can actually cross-foster pups from a not-so-good mother to a better mother and transfer behaviorally these characteristics. So the offspring, in the case of the females, become better mothers, so to speak, and overall they show less anxiety, and others have shown that animals that are less anxious actually may live, those rats, as much as 200 days longer on the average. So somehow this gets under the skin and can cause, affect the aging process. Studies in our laboratory looking at early life stress where you disrupt the nest so that the mother is not taking care of her pups adequately actually result in the hippocampus, at least, in the red on the left. When you challenge these animals with an acute stress, the gene expression is less able to respond. So there are less possibilities to respond in an animal that's received early life stress than an animal that hasn't. And we're trying to figure out what that means in terms of later adaptation. For example, treatment resistance to depression seems to be related in humans to early life abuse and neglect. So there are developmental issues for kids, which I'm sure you are aware of. Poverty and low socioeconomic status, coupled with the lack of stimulation by the parent of verbally the child, can lead to reduced vocabulary and also changes in learning ability. There's a famous book by Hart and Risley called Meaningful Differences, which follows this, and now one of the practices is to encourage parents to verbally stimulate their kids, and there are even devices to help kids improve their verbal communication and improve the kids' vocabulary. Chaos in the home, in poverty and because of disruption of the family can lead to impair the development of the prefrontal cortex, so there's less self-regulation, can lead to obesity and elevated blood pressure and cardiovascular reactivity relatively early in life, increased levels of inflammatory tone as indicated by poor dental health, and all of these then are also, as I said, because of the prefrontal cortex, related to impaired brain architecture and greater sensitivity to toxic stress. And then the adverse childhood experiences studies of Felitti and Onda and others actually emphasize abuse and neglect, increasing not only mental health disorders, but also physical disorders, cardiovascular disease and diabetes and so forth. So just very quickly to summarize some of the things we know about early life adversity and poverty, results in a smaller hippocampus, low self-esteem and greater risk as a result for PTSD. The amygdala is more reactive, as I said, because of these early experiences, more vigilant, and more likely then to develop anxiety and depressive disorders. The prefrontal cortex more affected, so it is less able to help the person self-regulate, so there's greater vulnerability for substance abuse, for mood disorders, lesser ability to plan and execute the kind of life that one needs in this modern society. So what can one do about it? And obviously, prevention is the most important thing. The nurse-family partnership is an example of an intervention that reduces, that helps parents have better relationships with their kids and improves, as demonstrated over 20 years of observation, does improve childhood outcomes. But as I've also said, things that when bad things have happened, there are things that are possible, illustrating that we can change the brain with experience. One of them I've already mentioned is regular physical activity. I've also mentioned the mindfulness-based stress reduction. If you reduce anxiety effectively, you can decrease amygdala volume, and this may be anxiety that's the result of some early life condition. And finally, the most important thing, of course, for anybody is finding meaning and purpose in life, and social support and integration are very important, and programs like the Experience Corps, getting, in this case, elderly volunteers involved in taking care of elementary school kids in the classroom. The health of the volunteers is better because they have increased physical activity, increased social interactions, and they're doing something that has meaning and purpose. And there are studies by Barbara Fredrickson, among others, showing that eudaimonia, or meaning and purpose, actually can reduce the overall inflammatory tone in the body. So the wisdom of the body, which is a term that originated here in Harvard, is really something that tells us, let's pay attention to our bodies and don't let our lifestyle push us over the edge. And we know that our modern lifestyle can work against and work against what is sensible and produce allostatic load. So with that, I'm going to turn it back to Linn.
So from the Rockefeller perspective to the clinical perspective, here is a family physician encountering a lady, and here is Helena. She's 54 years old, and she is married with 2 children. She has low education, and her new general practitioner, or family physician, finds a lot of long-standing problems in her medical record. Typical chronic complex diseases: hypertension, diabetes type 2, overweight, hypothyroidism, chronic widespread pain, that's one of the medically unexplained problems. She has recurrent airway infections and is bordering on chronic pulmonary disease. irritable bowel syndrome, depression with anxiety, and probably she has osteoporosis. She hasn't been measured, but she has had a fracture that shouldn't really have happened at the kind of accident. And she takes from 7 to 10 prescription drugs daily, depending on what she and her physician are trying out to work on her pain problem. And she still smokes despite advice. And then the medical students are told by me and others to encounter patients from a biopsychosocial perspective. And it's really a question, what is in that package? The perspective of biomedicine today is what we have decided to call silo medicine. It's a nasty word. We didn't invent it ourselves. We found it first time in JAMA, in the Journal of American Medical Association, but we adopted it immediately. The kind of list of problems that Helena has can be compared to silos. Each of the silos has its own life, in a sense, culminating in clinical guidelines for each of these diseases. And each disease is taken as something separate. The problem is that this fragmenting approach doesn't really work very well in practice. Family physicians complain about guideline overflow. A typical guideline for like diabetes type 2 coming out in Norway now is 250 pages for one single problem. And the idea that one size fits all, when to treat, how to treat, etc. And the worst part of it is actually the kind of uncoordinated polypharmacy that it leads to, because if you treat each of the diseases with the drugs pertaining to the disease, and the patient has 4 or 5 diseases at the same time, it can become quite toxic. And it is a terrible truth that death from side effects and toxic interaction between drugs is actually on the top 10 list of causes of death in the Western world. I shall not tell you where on this rank you find it, but it's quite high and definitely on the top 10 list. The strange thing is that people with multimorbidity, that is, people like Helena with several chronic diseases at the same time, they have existed, I think, as long as humankind has existed, but it has taken such a long time for advanced medicine to start really investigating the issue. Here you can see 2 major publications from the European side of the Atlantic. The British Medical Journal had a cover page, and the Lancet had a fantastic paper in 2012, I will get back to that, about the epidemiology of multimorbidity. And here you can see an editorial asking us to rise to the challenge of multimorbidity. What are we actually looking at? What is the problem when so many diseases tend to cluster in one and the same person? Is it just by accident? What is going on? We have to take a closer look. And then what we already know, and we don't need any more research actually to prove this, is that there is a very strong social gradient in multimorbidity. This is the Scottish paper from the Lancet. And you can see here that at all ages, if you compare the richest strata of the population, that's the black line, with the most deprived people, you can see that at least in the younger and middle-aged populations, there is a major difference. It will actually be a question of doubling the prevalence if you are deprived. So there is something associated with social realities here. Actually, in a sense, we have enough knowledge about co- and multimorbidity in the world, but in order to make a difference where you live, you have to make some local research as well to have something to throw to the politicians. So we have made some local research, and Bruce, as you can see from the author list, has been so kind to help us with it. We have a population study called Hunt Study in Norway. It's one of the biggest in the world. And this particular paper is based on about 48,000 participants in this affluent, relatively homogeneous Norwegian population. And you have a list of self-reported diseases to the left. And I am not going into the methodological pros and cons of this approach, but you can see a list of diseases. If the person has, or if you look at this column, or the bar to the horizontal bar, you can see the number of people with that particular disease. And If the person has only that disease, he will be or she will be blue. If another disease on the list is present, it will be red. If 2 or more diseases are present, it will be green. And if 3 or more, it will be a violet color. And as you can see, it's far more common to have 2 or 3 diseases than only the one disease. So multimorbidity is the rule and not the exception. And this has not been accounted for in medicine, and this is really serious from a primary care perspective. And if you try to find out what diseases are combined with what diseases, you can just as well look at the starry night. It's very hard, actually, to figure out the constellations, even though you know they're there. This is our PhD candidate, Margaret from Iceland, who has chosen this metaphor. So the question is, what is going on, actually? And I will go back to the year where I think most of the knowledge that we are building on in Trondheim came out. Of course, this has long roots, and this is not where it started, but here come some very important publications, at least from my perspective. The Adverse Childhood Experiences study from the Californian group mentioned by Bruce came out. And from this moment on, we know that there is a dose-response relationship between adversity in childhood and adult disease and multimorbidity. And this has been shown in other studies as well later. My previous mentor, Anna Louise Kirkengen, who is a Norwegian-German professor in general practice, she defended her thesis the same year based on qualitative, in-depth interviews with people who had suffered childhood sexual abuse. It's a fantastic book. It was released a few years later in Kluver Academic Press, and it tells how people with abuse experience complex and unexplainable to medicine kinds of health problems, as well as health problems that medicine knows and thinks it can explain. And the third thing that happened in 1998 was actually that Bruce McEwen published the allostatic load paper in New England that you started out with. And from my perspective, these 3 very different approaches, the clinical epidemiological study from California, the in-depth interview study from this Norwegian population by Kirkengen and Bruce McEwen, it's my golden triangle. It's where, within these limits, I can see so much happening now, and I am wondering what is the best word to connect, and I think the best word is embodiment. And that is a word I have not at all invented myself, because that word has actually been invented here at Harvard. Nancy Krieger. I have never met her, but this is a fantastic paper, and I want to read to you the sentences that are here, because if there is anything that rings true to the family physician in the front line, it is this insight that Nancy Krieger presents. I don't know how she could do it, because it's so beautifully written. And she says the following: recognizing that we as humans are simultaneously social beings and biological organisms, the notion of embodiment advances 3 critical claims. Bodies tell stories about and cannot be studied divorced from the conditions of our existence. Bodies tell stories that often, but not always, match people's stated accounts. And bodies tell stories that people cannot or will not tell, either because they are unable, forbidden, or choose not to tell. This is the clinical manifestation of difficult lives and adverse experiences. And I think this is something we have to bring into medicine. I'm struggling to teach my medical students this, and also the postgraduate GPs in our area, because if we start really understanding this and talking to people along these lines, medicine will become so much more effective in the front line. Stories. I was collecting evidence for a long time, mainly in my evening time, and I finally got around, together with my mentor Anna Louise and a professor in immunology and microbiology, Elling Ulvestad, to write a paper, originally in Norwegian, but it is also translated. And we chose the title, The Human Biology Saturated with Experience. And I think it was such a hard job to collect all this evidence and put it together in a theoretically sound manner. And I had to fight with the journal to have it accepted as an original piece of work, because if you are researching evidence that somebody else has collected, that is just something, yeah, it doesn't really count. But I think we have so much primary research, we have to look at it and put it together. We can't everybody collect more original data. We have to look at the data that is already out there, and there's so much going on now. Fantastic time to be part of this evolution. We have another little study from this hunt population where we were able to introduce one question about subjective experiences of childhood. And we have been looking at how this is associated with multimorbidity. And we have had the idea that allostatic load is the underlying mediator between experiences of childhood and adult disease. And as you can see here again, Bruce has helped us. In this figure, you can see a lot of diseases, the same self-reported diseases again in a somewhat different list. And we have the prevalence of each of these diseases along the x-axis. And then we have the different colors here represent different levels of childhood experience, from very good, which is dark blue, to very difficult, which is the red color. And what you can see for almost all diseases, not all of them, not cancer and not hypertension for some strange reasons, but for all the others, there is this dose-response relationship, which shows you that a difficult childhood, just subjectively reported in one question, is a predictor of a much higher risk of disease than otherwise. And I use the thyroid as an example because I don't think people are used to thinking about thyroid disease as typically related to your childhood. But there is something about it, as Bruce was mentioning in his case, the woman with the immunological disease. The immune system is part of this whole adaptation. So what I have prepared when I teach my students, and also actually people with much less education, I have stolen this figure from Bruce. He knows it and he has accepted it. And I am asking permission to talk about allostatic load as a balance between drains and gains. The pathogenetic part, the stress, the detrimental things are on the left-hand side, and the life-sustaining and resilience things are on the right-hand side. And since we are living in a dualistic medical world, I am dividing the medical literature into mental and physical, because I cannot make up for that, even though we shouldn't think that way. We have to work with what we have. And then I add all the world literature, and it won't get worse than this. But here you have like a 2x2 table, and you can see that you can somehow sort out lots of the evidence that's out there, because there are many individual papers investigating, for instance, overwhelming responsibilities. We are at the top left. That's my name for having a spouse who gets Alzheimer's disease, and you care for the person for many, many years with love, but it's also a draining experience. Or you have a chronically disabled child. You want to do the job, but it's tough. And I call this overwhelming responsibility. And we know it has an impact on telomere function, on allostatic load, etc. And you can read the world literature and like put the pixels into this picture. We know that injustice is bad for people. The Whitehall study has shown that people who experience subjective unfairness, they feel maltreated, and they get more disease and more cardiovascular disease than others. And you have the physical things that are well known, and then you have the more gaining sides on the right-hand side, and you find exercise and all this, sleep and all this. And I think this is an opening for discussing in the clinical situation with patients, where can we start? It's not obvious that you should start attacking smoking in somebody who has not been able to stop before. You could mention it, but perhaps you could rather talk about meaningful activities, or how is it to carry this responsibility. The whole point is that I suspect very strongly, and I think I'm not alone, that when the drains are much heavier than the gains, that is where you start fueling up under multimorbidity. So instead of looking at disease from a pure silo perspective, we could perhaps use the volcano metaphor. And I'm talking about risk. Of course, you can become multimorbid without having any adverse experiences in life. I'm talking about added risk here. And the idea is that allostatic overload is a common denominator that can fuel up under so many diseases. Once you get one, you have increased risk of several diseases. Bruce, I think you took part in writing about the biology of disadvantage. That's your term, or your milieu has that. Michael Marmot speaks about the causes of the causes. And Paul Farmer here from Harvard, he speaks about pathologies of power. I'm not sure if he's really speaking about allostatic overload, but it must be part of the same picture. So we have some very good terms that we can use to try to mediate and express this insight. And now comes the clue to the whole thing. You didn't say much about it, Bruce, but in theory, this can all be measured and monitored. And that is exactly the ambition of personalized medicine now, to monitor what's happening, to be able to predict and perhaps prevent things from going bad. And as I told you, I can see a best case and a worst case scenario now from this idea that we understand so much of the mechanisms. And if you look at this paper from 2011, this is about systems personalized medicine. It is written by 64 system biologists and one GP who actually was president of the World Association at the time for general practitioners. And here is the idea that the vision now is to let each patient be surrounded by a virtual cloud of billions of data points. And it's going to be unbiased by classification systems, and we will have new biomarkers. These people have understood that multimorbidity is an artifact to a certain extent of the way we think about disease. There is something going on much deeper. So the point is they have really understood many of the flaws of modern medical thinking, which is a good thing. The question is only, can we only solve it by measuring things, or can we actually find out without all those measurements? The IPOP is the integrated personalized omics profiling. And here you have 1 billion data points at several levels from the genome via the epigenetic markers, the methylome, and you go all the way to the metabolic various components that you can measure in the person's blood. And you do this over a lifetime. You start before the child is born, perhaps with the mother, and you go through like every 3 months or something, and you monitor the IPOP. And we are actually arriving at this very soon now because we have all this technology. We can measure, we can combine the big data. Google has already established this baseline study. Apple has this kit, and they remind us that our iPhones, they are actually powerful medical tools. So we are going into an era now where we can measure and monitor ourselves to an increasing extent. And here is the point where I think Greek mythology can come to our help. Are we going in the right direction? What questions should we raise now? Is it the narcissome that is being invented? Is there a risk that we can drown like the poor Narcissus? We can just become so infatuated by our own mirror image that the molecular me will be just what we can see, and we can forget all around us. We can forget about education, about equality, about justice. We can just take care of ourselves and monitor ourselves. We have written, or a PhD student of ours, Henrik Vogt, has written a fantastic paper that recently came out about the idea that now we are supposed to quantify our health. We are not only going to measure ourselves when we feel bad or sick, but we should quantify and monitor our health according to systems medicine. And here is another paper by the same guy, where we put the ultimate question to the test, getting personal. Can systems medicine integrate scientific and humanistic conceptions of the patient? Can we, by measuring everything, get to the point where we don't need to speak to people anymore? And the conclusion is, ultimately, systems medicine may also have to recognize that to faithfully model a human being, it's necessary to be a human being. It took us 10 pages to get to that conclusion. And you might laugh, but actually there are people who are really selling this idea that this is all you need. And then a bit of Greek history again. The Oracle of Apollo, the temple of healing also in old Greece, it had this inscription at the door, know thyself. I can't say it in Greece. It's something like gnotes hioton. I don't know how they spoke. Anyway, it was know thyself, and as our PhD student has pointed out, that is something different from knowing thyself. And that is actually the end of the talk. There is a lot that we haven't spoken about, especially the nature of these measurements. I can just promise they are there. And the question is, how are we going to handle this fantastic insight, the political nature of medicine? We know about the pathologies of power, the disadvantages and all this. Are we going to measure ourselves out of it, or are we going to act on a more political level? That's the main question, and here are the acknowledgements coming. Thank you.